Hi, good afternoon, everyone. Welcome to the session. Hope you got a great experience in this week. Before the session, I would like to know how many of you are the developers? Could you raise your hand, please? Thank you. Thank you, first of all. And the product owner or the project stakeholder? Okay, thank you. And the lovely architect. Okay, great. Thank you. So why will I ask you these questions? Because I do want to make sure after this session, you and your team could get the experiences on how you can build the solutions through the distributed design patterns. Okay, today I get extremely honored to co-deliver with my colleagues, Derek and Ken, to co-deliver the session. So I do believe that most of you had the similar experiences. When we design the solutions, we had better to co-work with different stakeholders. Like I just mentioned, we have product owner, we have engineer, and we have architect to think about which kind of trade-off we have to make the decisions. And then after the couple of discussions, we finally come up with the decision and just come up with the runnable architecture and make sure this can support the business and make it get a success. However, time flies. Something always gets changed, right? So the most way we would like to do is try to keep working on the existing solutions we have. Just like we can see the buildings outside everywhere. No matter which one new company decided to move in, what they can do. Perhaps they will depend on their preference and do more decorations inside the buildings. Otherwise, even they have to make sure the other elder buildings could be safe so that they can keep employees living inside. This is kind of way that we build solutions or software in an agile practice. So it's kind of while driving and changing a wire at the same time. Things that to build up a solution take a lot of time. We treasure the effort we have. So it is better to start from simple. To start from simple is highly recommended by Pete Glocks. His concept is to, perhaps we have to start from modeling the question we encountered. Most of the time, we build solutions is to conquer the challenges from real world, so that while modeling, we had better to think about all we have the information are really needed. So there will be a lot of challenges or decisions, confliction. So finally, if we can capture the only needed information and model it, then that would be the best one to go. So after we have the model, then what we have to do, if we cover and follow by the start from simple perspective, the easy way is to reside the model into the monolithic server, which is the so-called, include the storage, compute, and network. Then we can we can execute the service and make sure it can support all of the activities and make sure the business support. Okay, it's kind of a way that we start from simple. So start from simple could be a lot of options. Here I would like to share with you, if you gonna to use this approach, then to make sure you can take one approach like adaptive system design. Why adaptive is very important? Like we learned a lot from the traditional design patterns, adaptive pattern, right? We don't want to break the whole design at the moment. What we gotta do is to make sure that we can expend the least effort on the modeling, on the application, and even whole architecture. So take this approach, then you won't take the decisions on leading your team to adopt Kubernetes as the first time. I still remember a couple of times when my client come to me and then ask me to introduce how they can run applications on EKS. And then my first question is, what might be your DAU? Guess a number. Less than 50. Does this make sense? Yeah, I think most of you understand the challenge and why it's happened. So we do believe to start from simple could help us to reduce the learning curve and the waste of everything. So let's take a look on the traditional business. There might some of you are building the startup business, or you have been learned a lot from the startup stories. At the beginning, the business just started. So you can use the monolithic services to support incoming requests. However, time changes. Sometimes you encounter another challenge like the Cyber Monday, right? So imagine that you encounter the Cyber Monday challenges. How can you make sure your business could be a success? So the first step would be think about start from simple. So most of the time, we will try to replicate the single monolithic services as an application cluster, and then place it behind the load balancer, right? This is the easiest one. Yeah, we use these resources and machines resolve these challenges. But this also leads to another problem. There is only one data source or data basis to support the query or read or write operations. So then we have to counter the other challenges. So how we can do, let's take a more detailed case to share the story. There is the retail e-commerce, which is the unicorn retail. The company, they will support the customers to buy their preferred unicorn on website. And then in this week, the marketing team raised an idea. Like he told the team they would like to embrace the Cyber Monday. They would like to make sure their website could support the upcoming requests and unpredictable traffic. Furthermore, she also mentioned that there is a key new feature she would like to do, which is once each single one customer buy the unicorn, they can gain the rewards as a return. So the challenge is coming. Do you think it is easy to place the new features like the rewards point system into the existing one retail system? Otherwise, we need to separate the loyalty point system outside the existing one. Do you have any answer? Okay. I guess most of you don't like the answer. It depends, just like a consultant talk. But I do suggest that you can consider the end goal. We want to accept and support the Cyber Monday traffics. So imagine that the existing one retail services, it's not only support the unicorn inquiry, transaction, it do also include the other operations to support the company's business operations, right? So once we place the features for loyalty point awarding into the existing one, what will happen? The highly traffic will make some impact on the existing one. So based on this concept, we can think about it to separate it outside. And the further one reason is Cyber Monday will run once per year. So it is not necessary to put it on the existing one retail service. So in that way, let's think about how we can make the decisions. So the better way is to conquer and tackling a complexity in the whole system. So how we can do that? Basically, there is a popular approach like domain-driven design. So what is domain-driven design? It's a kind of way that encourages each one of you to collaborate with your team, like the product owner, like the engineer, like the architect, and any other relevant people who take care of the value stream for your services. Like I mentioned, we make the decisions in the previous minute I talked. We always covered what's the value we have to do, what's the value we treasure. So based on that, each one realizes the value, the terminology, the process, and everything they need, then come out the ubiquitous language. The ubiquitous language is kind of understanding for each single one who co-worked within a narrowized scope or a specific scope. They understand everything, and they can represent the implementation based on their needs and based on their knowledge in the real world. And the other one is the so-called bounded context. What is bounded context? Just like a small scope, it's to help us to focus on certain situation, to focus on certain problem we have to resolve. So think about it. What we mentioned about this unicorn platform, there are two topics that we would like to cover: the existing retail and the new coming loyalty points. Okay? So let's take a look. If we adopt the domain-driven design concept to build up the bounded context, what it might be. At first, we take a look on the retail context. In the retail system, each one customer, they can purchase the item. So once they decided to purchase a unicorn, and the system have to better to cover the transaction, the payment, then stock reservation, right? And it also need to take care about who is purchasing the unicorn. So we know that we need to also cover the loyalty platform. So the loyalty is another concept. So we had better to dedicate it to the other one, separated bounded context. So in the loyalty bounded context, it's focused on the point. So each time if a transaction is completed, then the loyalty point context should take the responsibility to calculate how much point should be rewarded and which type of the point will be used. Maybe it will be issued or redeemed. And also, we have to log the day and time, make sure it could be used like the expiration or any other usage by different contexts. So let's take a look. Since we have the two different bounded contexts, how can we make it work together and complete the whole process? So at the beginning, as a user decided to buy the unicorn, he can select the unicorn on the website. And then it decided to buy the unicorn. So the command is sending out through the mobile or web. And guess what? There should be a backend system like the retail context there. It should take care of all of the transactions inside. So what's the next step? We want to make sure there should be another boundary context like the loyalty point. It could take care for all the other actions. But this is a separated one. How can we make those boundary contexts commuted with each other? We don't want to introduce a dependency, right? In nowadays, nobody likes a dependency. So we can try to emit a domain event. What is a domain event? Domain event represents the most valuable and important status change in the specific domain that you really care about. So in this scenario, what we mentioned about is the transaction completed. So it is better to emit the event and then the loyalty point context can deal with the just publish out event to do further calculation. So let's map this concept logical design into the physical service design. So we can see, okay, there should be an existing one, retail service, and the other one, loyalty service there. So based on our discussion, the emitted domain event could be raised or published. So we can also cover the other kind of the event, like purchase canceled, purchase completed, and any other new coming event, which is the way we can have an elegant way to deal with the different communication. Okay? So We have this design to make sure we can start to experiment the distributed service systems. But we still introduce a lot of challenges, like the simplicity, scalability, usability, and performances. Because we do have more and more isolated or the distributed services, we need to have a way to achieve the challenges. So for now, I will invite Derek to introduce you a lot of the distributed design patterns to conquer these challenges. Thank you.
Hi, a very good afternoon, everyone. My name is Derek Chen, and today I'm the head of Unicorn Retail. As you've heard from Kim, we sell unicorns, and that makes us extremely popular. So when I heard from marketing that we're going to have a Cyber Monday sale with 50% off, I knew this was going to make my job very difficult. Who here doesn't actually like unicorns? Even if you don't, I bet your kids do, right? So you want to get in there and grab your unicorn the minute the sale starts. What does that mean? Spiky traffic. We're expecting a lot of traffic rushing to our site the minute our sale goes live, because you definitely do not want to tell your kid that you couldn't get a unicorn this year because you were too slow. So the unicorns are our most popular items, and inventory management is crucial to the success of our system. But how do we actually do that? Our strategy is to reserve a unit of unicorn the minute a user actually starts the checkout process. This helps us ensure that everybody who pays us gets a unicorn at the end of the day, and then we have a happy customer. And also, as Kim mentioned earlier, we will now start supporting adding loyalty points to the purchase so our customers can come back and redeem more merchandise at a later time. But let's take a deeper look at how we're going to implement the entire checkout process. So the entire workflow consists of 3 steps. First of all, we will reserve the stock once a user starts the checkout flow. This is to ensure any concurrency or risk condition issues does not result in anyone paying for the unicorn and not receiving a stock at the end of the day. If we have enough unicorn in the warehouse, we're going to reserve it for you for the checkout, and then we'll move on to try to deduct the balance from your user wallet. And yeah, you've got to upload and send some credit to our wallet because we're selling unicorns, right? So if you have enough balance to check out for the order, everything's happy, right? We'll move on to the next point, which would be to reward you with the loyalty points. And if that goes well as well, we have a happy customer with a unicorn. But as system designers, developers, and architects, it is our job to anticipate failures. And in this 3-step flow, could you care to guess where could go wrong? The quick answer is everywhere. So if the first step fails, it's not too critical because we haven't taken anyone's money, and it's okay, we will just let someone try to check out again. However, it gets a little bit tricky if the second step fails. If we are somehow unable to deduct the balance from the user's wallet for various reasons, perhaps there isn't enough balance in your wallet for this particular order to check out, or perhaps there's a system downtime affecting some of the components. When this happens, it means that we need to go back and release the stock that we have reserved for you to allow another user to check out that unicorn. Sounds logical, right? Because we want to make sure that everybody gets a unicorn at the end of the day. Now, the other point of failure is actually with the rewards points part. But is it as critical as the previous point of failure? I would like to argue that no, because at this point, we have actually completed a user transaction as far as the purchase is concerned. We have reserved the inventory, we have deducted the balance from the user, and we are able to ship it and complete this order and deliver this unit of goods. So as long as our system has captured all the critical information up to this point, we will be able to replay at a later time and reward the reward points to our users. And now you understand our strategy for this Cyber Monday. It brings us to the non-functional requirements of the system. So the critical part is really managing multiple step transactions within a workflow. And this is very common no matter what is your industry or your domain. So there are local transactions. And you can think of them as when we move the user from one step of the user journey to the next. And then we have the compensations. So the compensations are the ones when we undo a particular action, like I just explained earlier, when we fail to deduct the balance from the user. And we will have to restock the unit and undo what the first transaction has done. And that's considered as a compensation. We did our forecast from the previous year, and we still want to be sure that we will be able to reactively scale up to 1,000 transactions per second, just to be sure. And finally, for each step of the workflow, we should make sure that they can scale independently. As Kim mentioned earlier, replicating infrastructure across the board and putting it behind a load balancer is no longer the most economical solution. So, my dear architects and developers, which design pattern can we use to implement the checkout flow? Anyone thinks it's the anti-corruption layer? What about saga orchestration? Oh, I see a few hands up. Okay, what about bulkhead? You guys know your stuff, right? The answer is saga orchestration. Okay, but let me quickly touch upon the other two patterns. They are still useful. They are fundamental patterns that we should all be aware of. So for the anti-corruption layer, the main purpose is to do a translation layer when you have two systems that do not actually no longer depend on each other directly. Imagine you have a scenario where you're modernizing your system and you have part of the system that's strangled out with a new, say, data schema, new API endpoints, but you somehow still depend on the remaining old system. An anti-corruption layer is the mechanism where you can have a translation layer in between to make sure that both systems can still talk to each other and function as a whole. Now, bulkhead. Bulkhead is a pattern where we try to separate part of a service into a separate deployable unit. And the reason that might be important is that in case you have a sequential processing that depends on multiple steps, we want to make sure that the failure of one does not bring down the other service. And this helps us to ensure the resiliency of our system. Now, I would like to explain a little bit more on saga orchestration because that's what really helped me to solve my headache. So the saga orchestration is a distributed design pattern that we can use today. At a high level, what we have is an orchestration engine. You can think of it as a controller at the very top. And this orchestration engine's responsibility is to determine the routing of the particular transaction into various steps. So this will be a crucial piece of the puzzle to help us manage this multi-step workflow that we have for the checkout. And I explained earlier, there's also it's critical that it can help us manage the local transactions and compensations. Now, I'll give you another example. The difference between transaction and compensations is a little bit like Newton's third law in physics. Every action has an equal and opposite reaction. And our orchestrator is going to help us manage that. But orchestration is actually not the only way we can implement a saga pattern. The other option is called choreography. And if you think about it, the key difference is that the business logic and the routing of the particular transaction within the workflow is more distributed in a choreography manner. So we no longer have an overhead controller that decides and determines where is the next step for this particular transaction. The difference is like taking an Uber, right? When you have an orchestration, you just want to enter the workflow and then you want to define where is the destination. Where choreography is more like driving the car yourself. At every red light, you need to decide which lane to go into and where to turn in order for you to reach a destination. The goal is the same. We want to make sure our system states are consistent, but there are just different strategies to implement them. The next question would be, so which is the better one? And in our scenario, we have decided that orchestration is a slightly better option for us because we want to achieve the least amount of effort for future changes. So orchestration, we can leverage on managed services provided by AWS to actually reduce the amount of build effort at a very initial phase of the development. Second of all, because of its centralized nature of orchestration, it makes day-to operation a little bit easier. When something goes wrong, you'll see where the fire is. As compared to a more distributed version in choreography, you have to go to different components to search the logs and find out exactly what happened. So let's take a closer look at how does orchestration actually work. Now, this is our workflow that comprises of 3 steps: inventory management, user wallet deduction, and rewards points. So for every step, there is an action and a compensation. So for inventory, there's reserve, and there's also restock. For user wallet, there's debit and also credit. And finally, for rewarding points, we have issue and redeem. So every of these transactions has a twin that does the exact opposite, so we can fall back and ensure the consistency of the states in our system. But in our scenario today, we don't actually have to worry about too much with rewarding points because our colleague will actually take care of that, and we'll share more about that later on. So what we'll do is that if the first 2 steps are successful, we'll be emitting that domain event that Kim talked about to the next domain. And we'll let the loyalty domain to handle the complexity later on. In summary, in the retail domain, we'll be implementing the saga pattern. This will help us ensure the state consistency during the checkout process, making sure that every person who checks out has a unit of unicorn reserved for them, and we can successfully deduct the balance required for the order. Now, let's take a look at the system architecture. So our user will be interacting with our system via CloudFront and through API Gateway. But what's interesting is that we'll be implementing the orchestration engine using AWS step functions. You can see that within AWS step functions, we have 2 Lambda functions taking care of the inventory reservation and also the user balance deduction. And if everything is successful, we would then use Amazon Event Bridge to send this domain event to the loyalty domain. That's the happy flow. But as I mentioned, this may not require as much complexity as a distributed design pattern. If we say we only care about the happy flow, if you ask a junior engineer, we can implement it in one machine, no problem. However, the problem is when we need to deal with the compensation and the routing of the workflow dynamically within the system, within the orchestration engine. So we need to implement the compensation actions in Lambda functions as well. So the orchestrator will be able to navigate and direct the transaction to where it should go to. And finally, we'll be storing the user data and transaction data in Amazon DynamoDB. And this will help us to do the replays and the recoveries that I've mentioned earlier in case it fails at the rewarding points step. Now let's talk a little bit more on step functions state machine. AWS step functions uses what we call the Amazon states language, which is a declarative language that you can define your workflow and with a visual presentation as such. There is a graphical interface that you can drag and drop to invoke services, to have evaluation blocks, and to direct basically replicating your workflow with AWS step function. So as you can see here, we're starting from the very top, and we're invoking our first Lambda function to reserve the stock, the unit of unicorn, and then we try to process the payment. If everything goes well, we use the event bridge to emit the event to the loyalty domain. Otherwise, we'll compensate and go back to release the stock for our next user. Let's see this in practice, shall we? Now, in this situation, I do not have any value in my user wallet currently. And you can see that now I'm trying to check out one unicorn, and there's sufficient inventory in our system right now. So by theory, our reservation of this unicorn should go through, but it should fail when it comes and try to deduct the balance from my user wallet. And let's see what happens. Nothing surprising there. You would expect this from any e-commerce website. But what we are interested today is what happens behind the scene. And what you're seeing here is the trace of the transaction within AWS step function. It has a graphical representation of every transaction that gets processed and tells you exactly which path the transaction took to reach an end state. So we can see here that we were able to reserve the unicorn for this user's checkout. However, when we come to try to process the payment, it fails because there's not enough sufficient balance. And our orchestrator routes the transaction to the compensation action of step 1, which is to release the stock for another user to check out. Now, let's see what's with the happy flow. If we have enough money in the wallet, and we also have enough inventory in the store, and the checkout is success. You see that the wallet balance has been deducted, and the stock has been reduced from 5 to 4. Nothing magic. You see this in everyday e-commerce platform, but this is how to manage the complexity behind the scene that makes a difference here. And this is the trace for the successful transaction. You can see that the difference between this and the previous trace is that at the third step, we are now able to process the payment successfully, and thus it routed to the branch where we are emitting an event to the loyalty domain. And just like my workflow, now I will pass this event over to our loyalty domain expert, Ken, to let him tell you more about this.
All right. Thanks, Derek. Good afternoon, everyone. My name is Ken. So today I will be your domain expert on the loyalty domain. So I will be talking about the business requirement and also the distributed design pattern that we could use to resolve the loyalty domain challenges. So I would like to cover what we present so far from Kim and also Derek. We applied the domain-driven design concept to break down the business domain into retail and loyalty domains. And we also applied the distributed design pattern, the saga orchestration pattern, and implement using the step function. And after that, we emit the events, the purchase completion event to the loyalty domain. And before diving deep into the technical solution, I would like to provide a little information on the basic requirement of the loyalty domains. So first thing, the loyalty domain is going to capture the business significant events from the other domains. For example, in our use case, it's going to be the purchase event from the retail domain, or it could be the registration event from the profile domain, or it could be the review given events from the user feedback domain as well. And after that, once the event has been captured, the loyalty domain needs to verify if it's match the campaign business rules. For example, in our use case, the purchase event, if the amount is more than $100, is the registration is the first time, or the review has been given on the eligible contents. And after that, the loyalty domain is going to trigger the action to provide the benefits or the reward to the customer. For example, this could be the cashback. So in some retail platform, you're going to see that when you purchase something, you're going to get cashback to your wallet, something like that. Or you're going to get the voucher, or you're going to get the coupons. And also, you can get the points as well. And for us today, we're going to talk about the point system and how we're going to solve the challenge using the distributed design pattern. So let's take a deeper look into the point system of the challenge of the point system. Assume that me as a customer, I got the 4-point entries for 4 days like this. So we can see that the total point balance is going to be 450. So basically, it's the aggregation or the summation of every record on this screen. But normally, things going to be more complicated, right? For the loyalty domains, the requirement is going to be something like this, that we can define the expiration period. For example, in this case, I define the expiration to be the 3 days. So in this case, the total point balance is going to be 350. Right? The first record is going to be excluded from the calculation. And this comes with the challenge that we're going to face. So right now, you can see that we cannot use the single record to store the point balance, right? To use just only the latest update. Because it is possible that some portion of the points can be expired any point in time. And also, if we store the data too fine-grained, that could be the potential latency. For example, if you have to get the up-to-date balance every time the customer query for the balance during the high throughput, that will be they're going to consume a lot of computing power and the resource utilization as well. And sometimes we may need the batch or long-running process to clean up the expired points, maybe every year, maybe every month, maybe every week. So that's a challenge that we need to face. And lastly, the requirement for the point expiration need to be very flexible. It could be by days, it could be by months, it could be by week, or it could be by years. So can you imagine what kind of distributed design pattern that we could use to resolve this challenge? Can you guess? The A1, the event sourcing? The B? Can you raise your hand? Or the C, the stratigraphic pattern. And yes, the correct answer is the event sourcing and CQRS that we're going to use for resolving this kind of challenge today. We cannot use the stratigraphic pattern because this is the pattern that you're going to use when you refactor your application from monolith to microservice. And you can slowly route the traffic into the newly created microservices. But in this case, today, we're going to talk more about event sourcing and CQRS. So trust me, I'm going to explain about the CQRS for those who don't know what is the CQRS. So let's go further to the first step first. So right now, we're going to apply the event sourcing and the CQRS into the loyalty domains to solve the challenge that we just presented earlier. First, let's talk about event sourcing. Event sourcing is a pattern for persisting the state-changing events of the business domain as a series or the list of events. And the new event is going to be appended at the end of the list of the events. And the event itself is going to be immutable, so it cannot be changed. So now let's have a look. Instead of storing the data like this, so if you think about the point balance, you may think about the data structure like this, that for me, Ken, account Ken, I have a point balance of 250. The latest update is 28th of November. And when we got any new transaction, we're going to update this record, right? Instead of storing the data like this, we're going to store the data like this. We're going to have a point service, store each individual transaction into the event store. So for now, for example, I got 3 transactions. The first 2 are the point issuing transaction for 100 and 200. And the last one going to be the redemption transaction for 50 points. And you can see that the total point balance is going to be the same if we aggregate the data on the event store. And after the point service persists the data into the event store, it's going to emit the events so that the other domains or the other service can consume and process the data, So now let's talk about CQRS. So you can see what the CQRS stands for now. So CQRS stands for Command Query Responsibility Segregation. So this means that for this pattern, we're going to break the command and query apart to improve the performance of the write and the query itself as well. So this is based on the assumption that there is no perfect database that will be suitable for every use cases. Because of normally when we got the requirement, we're going to design the data model and store into the database. And most of the time, we will get another requirement to pull the data to display on the screen or the API in different lead models. And this is going to cause a lot of consumption on the CPU utilization if we not decide well. And like I said, there is no perfect database for every use case. So what happens is we need the pattern that's going to enable the representation of the read model in different persistent model. So with CQRS, we're going to achieve that goal. And the CQRS itself are closely related to the event sourcing pattern. So right now you can take a look. Now we break the command handler and the query handler apart. The command handler is going to receive the incoming request for writing, the point issuing transaction, for example, and then store into the event store. And after that, the event is going to be published and will be processed by the projection engine. And the projection engine itself is going to process the data, transform, and then store into another data store, which we can call it materialized view. And at last, we're going to create a query handler to pull the data from materialized views for API or the UI. So now let's see how it works on the point system. So now we're going to create the point command handlers and the point query handlers. The point command handler is going to receive the incoming request for the command, the point issuing transaction or the point redemption transaction, and then store into the point transaction database. And after that, the event is going to be published and consumed by the projection engine. And then the projection engine is going to calculate the daily balance and insert or update into the daily balance table. And at last, we're going to have the point query handler to select the daily balance from this table. So now let's see how the data looks like in action. So this is going to be a little mathematic, but trust me, it will not be too complex. So now we have the point command handlers receiving the incoming point issuing transaction for 100 points for direct on the 27th. And then the point transaction event is going to be emitted. And then we're going to have the daily balance projection engine to process and insert the data into the daily balance table. So now Derek is going to have the points for 27th of November for 100 points. And on the same day, he got another point issuing transaction for 40 points. So now you can imagine the daily balance projection engine going to increment the value into 140. And again, on the next day, he got another point issuing transaction for 200 points. So now the daily balance projection engine going to create the new entry for the 28th. So here, we're going to see the 200 points as a new entry on the table on the right. Now, on the same day, Derek performed the redemption transaction for 50 points. So what happened is the daily balance projection engine going to deduct the 50 points from the 27, and this is based on the business requirement. But normally we're going to deduct the oldest point first, right? It will be a little weird if the business decided to deduct the newer point. So this is a normal requirement. And at last, on the next day, Derek performed the redemption transaction again for 100 points. This is going to be a little more complicated because from the previous one, the total point balance on the 27th is 90. So now the 90 points is going to be deducted to 0. And the remaining 10 going to be deducted from the 28 point balance. So now Derek going to have the total point balance of 190. So with the CQRS, you can see that we're going to separate the read and write. And now the right side on the left is going to be append only. So now on the right, we can receive so many requests because it's a very simple insert statement. But on the right-hand side as well, we are dealing with the smaller data, smaller amount of data. For each person, it's going to be just 365 records a year. So this is much lesser than the whole transaction that we have. So basically, we downsampling it into another read model. And we can see that we can set the expiration logic to be any day, any month that we want. And this is the benefit of the CQRS. And now let's have a look on how the solution is going to work on AWS. So now we have a user perform the purchase transaction to buy the unicorn on the retail domain. And after that, the purchase completion event going to be emitted to the Amazon Event Bridge, which is a managed event bus provided by Amazon. And then the event going to be trigger the lambdas for campaign processing. This campaign processing lambdas going to process if the incoming event matches the business rules. If the event matches the business rule, it's going to trigger another lambdas, which is a point command handler. This is where we start the CQRS pattern to issue the points. And here, we're going to store the point transaction into the DynamoDB table, the point transaction. And after that, we can configure the DynamoDB stream to capture the change from the DynamoDB table. And this stream can be consumed by the daily balance projection engine, which is implemented in Lambdas as well. And after the data has been processed for the daily balance, it's going to be stored into the daily balance table, which is another DynamoDB table. And at last, we provide an API for accessing to the web using API gateway and Lambda for the query side. And this is a holistic view on how we implement the CQRS pattern on AWS. So now let's see how it works on the demo. So here we have the point center on the top right. And when you click on the top right, it's going to pull the data from the daily balance table using the point query API. So we can see that right now we're going to have 3 entries for points for 3 days. And the total point balance is the summation of each day. And this is the data that we pull from the daily balance table, like I mentioned. So putting it together, the solution that Derek just presented and the solution that I just presented earlier, we have a user performing the action with the retail and the loyalty domain. Once the user opens the website, we can use the Amazon S3 to store the static content, which is the HTML, images, or JavaScript files. And then we distribute to the edge location using Cloud Font. And after the web has been loaded into the web browser, it's going to interact with the backend. So we're going to use the API gateway, Lambdas, and DynamoDB to provide an API for the CRUD operation for wallets, product, and purchase. And after that, we use the step function to manage the local transaction to implement the saga orchestration pattern. And once the purchase transaction is complete, we're going to emit the events into Amazon Event Bridge, which is going to trigger the event sourcing and CQRS pattern that I just presented earlier. So this is the whole solution for these 2 domains that's implemented the distributed design pattern for saga orchestration and event sourcing and CQRS. And that's all for the information that we want to present today. So I would like to summarize the key takeaway for this session that Kim and Derek presented earlier. So first, we need to align the business strategy with the software architecture domain. We can embrace the domain-driven design practices to break down the business domain into retail and loyalty domains. And like I said, like Kim says, that we should start from simple and use the adaptive design principle to slowly evolve our architectures. And after that, we can select the right architectural pattern to use that's suitable for the use case. And in our example, we apply 3 distributed design patterns in this use case. The first one is saga orchestration. The second one is event sourcing. And the last one is CQRS. We use saga orchestration to manage the local transaction and also compensation transaction as well. And we use event sourcing to gain the auditability and state reconstruction abilities for the loyalty domains. And at last, we use CQRS for improving the write and read performance, and also the capability to represent the read model in different persistent model. And if you want to dive deeper, I would recommend to check out the following resources: the cloud design pattern, architecture and implementation on the AWS prescriptive guidance. So you can explore more of the distributed design pattern and implement and deploy on the cloud. And also the code sample for this presentation, we just published on AWS sample. So you can check it out as well on how we actually implement the code, follow this kind of architecture and design pattern. And the code itself is runnable using CDK, so you can try. And that's all for today, and thanks for joining the session. I hope this session is going to be benefit you all and provide an idea to design and develop the distributed system and deploy in the cloud. And if you have any question, please reach out to us after the session. We will be sticking around here for a while. And please complete the feedback survey on the mobile app so that we can improve in the future session. Thanks.
Thank you.